Hey, welcome. So every single day, you're creating and using just a massive amount of digital stuff. But have you ever really stopped and wondered, where does it all go? Well, today, we're going to pull back the curtain on the incredible technology that stores our entire digital lives. Let's dive in. I mean, seriously, think about it. Every photo you snap, every song you download, every little document you save, it has to exist somewhere, right? It can feel a little abstract, maybe like it's just floating around in the cloud, but it all comes down to a real physical place. So, where is the actual home for all your data? Well, the answer starts with this: a storage device. This is the physical gatekeeper to your digital world. It's the piece of hardware whose whole job is to read your information and write it onto some kind of physical material. But, that actually brings up a really key distinction. And this is the perfect way to think about it. The storage device is like the bookshelf. It's the structure, the thing that holds and organizes everything. The storage media, on the other hand, well, that's the books themselves. That's the physical stuff, the disks, the chips, that actually holds the information. See, you need the bookshelf to be able to find and read the books. Same idea here. Okay, so it turns out not all these digital bookshelves are built the same way, not even close. In fact, pretty much all the modern storage tech we use can be sorted into one of three distinct families, and each one has its own totally unique way of holding on to our precious zeros and ones. And here they are, the big three. First up, you've got magnetic. That's the classic workhorse. Then there's solid state, the little speed demon living inside your phone. And finally, you've got optical. You know, the world of shiny disks. Three very, very different answers to the exact same problem. So how on earth do these things actually work? Let's pop the hood for a minute and take a peek at the fascinating mechanics behind how each one physically saves and gets your data back. It's actually some pretty brilliant stuff. First, we have the classic hard disk drive, or HDD. This is pure old-school mechanics. Just imagine a tiny record player on hyperdrive. You've got these metal platters spinning incredibly fast. We're talking thousands of times a minute. And this tiny little read-write head on an arm zips across the surface, using magnetism to flip tiny spots into a 1 or 0. All that physical movement, it takes time, which is why these drives can only go so fast. And then we have solid-state drives, or SSDs, which are basically the polar opposite. The most important thing to remember is this: absolutely no moving parts. Zero. Instead, your data is stored as a tiny electrical charge inside millions and millions of little cells. Because it's just sending electrical signals, it can find any piece of data almost instantly. No waiting for a plotter to spin into the right position. And that right there is a secret to its incredible speed. And finally, the disk family: your CDs, DVDs, and Blu-rays. For these, a super high-precision laser is the star of the show. It literally burns microscopic bumps onto the disk surface. The flat areas are called lands, and the little bumps are called pits. When another laser reads the disk, it sees the change between a pit and a land and interprets that as a 1 or 0. Pretty clever. Okay, so we've got three completely different technologies. So which one is the best? Well, as you can probably guess, it's never that simple. Choosing how to store your data is always a balancing act, this constant game of trade-offs between three really critical things: how fast it is, how much it costs, and how durable it is. And this table just lays it all out perfectly. Let's break it down. Need a ton of storage for cheap, maybe for backups? Magnetic is your answer, but you're gonna sacrifice some speed and durability. What if you need lightning-fast performance for your laptop? Well, solid state is king, but it's going to cost you a premium for every single gigabyte. And for long-term stuff like movies or music archives, optical is dirt cheap, but it's also painfully slow and easy to scratch. See? Trade-offs. This quote right here, it just nails why SSDs have completely taken over all our portable gadgets. I mean, think about your phone or your laptop. You're moving it around, you might bump it, you toss it in your bag. A traditional hard drive with all its spinning parts would be at risk of failing. But an SSD, it just doesn't care. It has no moving parts to break. That durability is its absolute superpower. All right, let's switch gears and talk about size. And I don't mean the physical size of the drive, I mean its capacity. The journey of how much data we can cram into a tiny space is honestly one of the most incredible stories in all of modern technology. But to really appreciate it, we need to get our units straight first. Okay, so a real quick refresher on the scale here. A kilobyte is 1,000 bytes, A megabyte is a million, a gigabyte is a billion, and a terabyte is a whopping trillion bytes. Now I want you to hold on to that definition of a megabyte because you are about to see just where this whole story began. 3.75 megabytes. That's it. That's less storage than a single high-quality photo from your phone today. This was the absolute maximum capacity of the very first commercial hard drive ever sold. Now, prepare yourself for the contrast. Just look at this. It's wild. On the left, you have the IBM 350 from 1956. It was the size of a huge refrigerator and it held less than 4 megabytes. On the right, a modern micro SD card. It's smaller than your fingertip and it can hold over 256 times gigabytes. That is an almost incomprehensible leap in technology. It's not just progress, it's staggering. So when you really step back and look at it, the journey is just mind-blowing. From magnetic platters the size of a fridge to flash memory you can balance on the tip of your finger, and the evolution is just getting faster and faster. We create an unimaginable amount of data every single day, which leaves us with the ultimate question. What comes next? What will the next storage family look like to hold the future of our digital world?